Kelsey said, why did the radius have to change too? Because if you're in a cone, the top of the cone is going to have a larger circle on top, right? And as the water level decreases, you're going to go lower and lower in that cone. And therefore, the circle is going to decrease, meaning the radius has to decrease also. Let me know if that answers your question, Kelsey. Okay, now for the big mama question.
Yeah. So if you're the person that sent us this question, you're gonna have to bear with us. It's been a bit. But I think we should be able to figure this out. Hopefully.
Yes. Okay.
Okay. So, Jane and I have done a little research. And we're going to write out some stuff, okay?
Okay.
Moment of inertia of a rectangle is Ix equals BH3 over 12, okay? And the radius of gyration is going to be H over square root 12. Okay?
Okay.
Triangle is going to be I of x is equal to b of h cubed over 36. And then we have h over the square root of 18 for the gyration. And then for a quarter circle, we have I of x is equal to I of y, which is equal to 0.00 or 0.055 r to the fourth. And we got k of x is equal to k of y, which is equal to 0.005 r to the fourth as well.
And what does the k stand for?
Sorry, that's the, I forgot to write k's for all the rest, but this is a k of x. This is a k of x.
Okay.
So this is that's the radius of gyration.
Gotcha. Okay, so that's the radius of gyration. Gotcha. Okay, and Kip, all these equations you just wrote down, somebody has done some integration to solve for these moment of inertias of these different shapes. Is that correct?
That is correct.
Okay. All right.
Okay. Now things get a little more interesting, all right?
Okay.
So now this is where things, yeah. So we need to figure out, Jaden, what shapes we have here and what shapes we want to use to find these moments. Okay, so we're gonna need to find a whole bunch of separate moments of inertia and kind of add them together to get our final.
Okay.
So I'm thinking we could do something like this, and I'm assuming that this is a straight line. Maybe it's not. Let's see here. We've got 5 and 11 and 7 and 11, so that's 9 inches. No, those are not the same, so we don't want that rectangle. That's not a rectangle.
We could probably chop it down here. Boop. Then chop it from start of this circle. Boop. that gives us a rectangle, right? And we could chop it right here. Boop. We get a quarter circle.
Yeah.
Chop it right here. Boop. We get a triangle.
Yeah. I don't think we need to chop it all the way, right? So we can leave this rectangle like that. Right?
Yeah, and then this one also, right?
Yeah.
Yeah.
Is there anything else we can simplify?
That looks, I think that's good, right? We have a rectangle 1, 2, 3. We have one half circle and one triangle. All right, not half circle, quarter circle.
Okay.
Okay. Oh boy.
So let's start.
So let's find the distances real quick. Or does that matter?
Oh, that's gonna matter.
Yeah, base times height, right?
Yeah.
Okay.
So
this
here, let's label each
is
one of these
5.
so we know what we're talking about. So we'll call this 1. We'll call this 2, 3, 4.
Okay.
So I'll take 1, 2, and you take. Anyways, let's find the. I'll find the lengths for 1 and 2. If that works.
Okay. Yeah. So that's 5 and 11. Oh, we can label this 5. So it's 5 and 11. Here. Oh. Then 3, 4,
And
5.
10, comma.
Is,
Jane, how's your math coming?
and that's super good, dude. Super good. For the triangle, we have height 3.
Okay. So the
On the
height
base
is gonna
of
be
5. Oh,
7.
oh, just kidding.
16.
What?
Okay, so we got 10.
Okay.
16. Number 4, we were gonna want the radius,
What
I think,
was
right?
the
Yeah, we
radius?
just want the radius.
It's just 7. Yeah, and it's 7.
Okay.
Okay.
We're killing it so far. Anyone have any questions up to this point, what we're doing?
Okay.
Anyone at all? Questions?
Whew. Okay.
Now this is we're gonna get
I'll keep an eye on the chat to make sure nobody asks questions.
So
All right.
now I'm still trying to figure out what it is we're exactly trying to find.
So the moment of inertia about the x and y axis. So I guess we would find the moment of inertia for each shape we did, right?
Right.
And then if we add them all together, is that going to equal like the overall?
You wish.
Yeah, that's what I was thinking. That'd make it nice.
So there's this equation that we're now going to need to use, which is how we add all the inertias together. Which is, nu I of x, right, of the whole thing is equal to the original I value of, let's see here, how does this exactly work? I'm looking it up here. What is the I of x in this case? Get the summation of the moment of inertia of all the shapes using the transfer formula. Okay, so we need to transfer these, Jaden, about the center, which is this. So we have our I of x, right? And then we're gonna this times the area times the distance. So for example, if this is the center of this thing and this is the center of this one here,
Okay.
we need to find it's this distance.
Yeah.
Okay. Which I'm assuming is gonna be what we're solving for. Maybe. I don't know. Still a little confused here.
That would be the radius of gyration, right? Or no?
I don't know. We're getting there, Jaden. We're gonna figure this out together.
Yeah, we are.
Any questions, please tell us your questions if you have any so far, or any comments maybe help. I don't know. Okay. Oh, and
yeah, if you're the one that asked this question, and if you've already started it and have figured it out, let us know.
Okay.
Okay.
Because see.
So pulled out the handy dandy calculus book, Kip.
Calculus book.
I need to figure out what. Let's see.
Okay, Jaden, the question is, do you think we can find the center point based on the shape of this object?
Find the center?
Yeah. Not like the mathematical center.
Find the.
Because if we turn this, because couldn't we turn this thing kind of into a rectangle like this, right? And find the center of it.
Yeah, we could. And same with this part, yeah.
Yeah. So let's
yeah,
do
we
that.
could.
Let's go ahead and do that so we can find the center of this thing.
Okay.
So we do 17.
So that means our
plus 5 is equal to 22, right?
And then 16 is the other side.
So the center of this object is going to be
8 up and 11 in the middle. Right?
Yeah, so this is going to be 8, and this is going to be 11.
Does that still... But that changes because of these corners that are cut off, right?
What? So
doesn't that change because of our corners?
No, because that's the center. So we're gonna call that our axis, okay? So that's our axis. That's gonna be the center. And you know that. So that's not. Yeah, there we go. let's go ahead and do that. Make that nice and big. And then from there, we can go ahead.
Sorry, my line's a little off.
And solve for this. So now we can figure out what our D is, right? So our D is going to be the center.
Okay, yeah.
So, can I copy this slide, and then erase everything and keep going? Duplicate. Boom.
Ooh, did it work?
It worked. Okay.
Heck yeah.
So let's erase some of these things. I mean, I feel like, okay, so we're gonna solve first for, we're gonna do number 1 and work our way around. All right. Okay.
Duo number 1. Okay.
So we're gonna find the center of number 1. So we've got 1, right? And we're gonna say this is equal to, so we're just looking at the x distance first, right? And so we've got,
right.
So the center of that is gonna be 4. And so 4 minus, what did we say that was? 16? No, 4, 11. So we're going to have 4 minus 7, which gives us, or 7 minus 4, right? No, 11, which equals 7. Sorry, there we go. So that equals 7. So the center of this point in the x, 1x is equal to 7. Okay. And then from there we can use this equation, which is I of x is equal to our I plus the area of that times d squared, which d squared is the d is our 7. So we get I x is equal to this big thing up here, b or h cubed over 12 plus the area of a rectangle, which is base times height times d squared. Okay? So this is number 1. Okay? So Jaden, we're going to have to go ahead and do this for every single one of these different rectangles and triangles and whatnot that we have. And then from there, we're going to go ahead and sum them together. And that gives us our I of x. Okay. Which I believe is going to be the moment of inertia about the x-axis. And then we're going to have to do it again for the y, but luckily I think for most of these, the y and the x are going to be pretty similar. The only thing that's going to change is our distance, I believe.
Right.
And then from there, as far as the radius of gyration it goes, that one I'm not as sure about. So I'm not sure how far we want to go.
And then the polar moment of inertia. And the polar moment of inertia is just the Ix plus Iy. Right? I think that's what it is.
Yeah.
Yep, my handy dandy calculus book. Whew, coming in handy. Okay. So let me just re-ask this real quick. Kip, I'm going to use the cool laser pointer.
Okay.
So this center, are you saying that is the 7?
Yeah, yeah. Exactly. So I'm saying, here, I'll pull out my laser pointer. So I'm saying from here to here, right? This distance is 7.
Right.
Okay.
Okay. And
So
you're claiming this is the center of the little rectangle, right?
yeah, exactly.
Okay.
So
Wouldn't that center be
it's gonna not be
half of
exact
9, so 4.5, and then
3.5.
4.5, and then
Yeah,
3.5? Yeah.
you're right. So it's not 4 minus 7. It's 11 minus 3.5, which gets you 7.5.
3.5. Yeah.
Thanks,
Okay.
Jaden.
Yeah.
Okay.
Okay.
So
Let's. I'm gonna start writing some of these down. So there's 3 rectangles, correct? 1, 2, 3. Yeah. Okay. This is fun stuff.
yeah, it is. A little stressed, but we're killing it.
Heck yeah. um, I mean, we're lucky we have these equations already
Yeah, we are.
done for us, or else we would have a whole bunch of integrals going on.
Yeah, but the integrals might actually help me understand what it is that those equations mean, but oh well. That's okay.
That's true.
All
You
right.
can derive it later.
Yeah. So if we go ahead and do I1 x, we
So start solving that.
so all right. So we get I of x equals base times height. So we've got 9. I deleted our trusty little deal here. 9 times 7, and this is cubed. I think, or is it just the height that's cubed? Shoot. No, yeah. No, it's just the height that's cubed, I believe.
Just the height.
Which means our y is going to be very different. Yeah, it's just the height cubed.
Okay. Maybe Kip, we just do a couple of the x's, or maybe all of the x's, add them together,
Yeah.
write down the y equations, and the person that asks this question can do the math themselves, yeah?
Yeah. Agreed.
And then at the very end, they can find out that the polar moment of inertia, you just add the x and the y together. Because this is a complicated question. It is very involved, I would say. And I mean, just from what we've done so far, I feel like I could solve this as long as I write out
Yeah.
all of my
So
stuff,
just to
right?
be clear, the moment of inertia of this whole thing would just become, for the I of x, right? It would be I of
It'd be the
plus 1
summation
plus
of
a d squared 1 plus I 2x plus A2D2. That almost sounds like R2D2. A2D2.
A2D2.
Plus A3 or I x3 d A3d squared 3 and so on and so forth, right?
Yeah.
And
Go
so I feel
through
like we have
each
done the
object.
hardest part of this question. The part
Right.
that I'm not sure about is the radius of gyration about the x and y axis.
I think, 1 second, I read that just a second ago. Do. Maybe I looked it up. It's defined as the radial distance to a point which would have a moment of inertia. Okay, the total mass. Okay, yeah, still confused about that.
Because to me that sounds like the same thing as the moment of inertia. Right? Wouldn't that have the same... Oh, I guess no, we're calculating the moment of inertia.
Oh, real quick tip, we got a comment. YouTube wouldn't let me comment before, but now I can basically. And if this is going to take too long, you can skip onto something else. You are killing it though. I asked you because I don't know how, at least showing the equations help. So, like we were saying, writing down these equations, that basically took a long time,
Right.
but it sounds like they have at least a start on the question now.
Okay.
Comment again, ask if you want any further, let us know. Kip, what do you think? Should we end the question unless they have something else to ask?
Yeah, I think well, let's see here. I don't know, Jaden, do we have anything else we're doing tonight? No one else has sent us a question that I'm aware of.
Yeah, I guess not. Yeah, we can continue.
We can keep struggling. People can watch us suffer. Okay. Well, let's just see if we can figure out the radius of gyration part here.
See what that means. Yeah.
So
Okay, in my
that gives
book, the
us our
radius
moment.
of gyration of what is that?
Here we go. I'm gonna Google. In the meantime, we'll figure this out. Okay.
Yeah.
Dude, good old Wikipedia is gonna help me out here.
Yeah, I guess we can ask radius of gyration.
Okay. Radius of gyration is the root mean squared distance of a particle's axis formula. So we've got r squared 1 plus r squared 2 plus r squared 3 divided by n. So...
Oh, that's what you wrote down, right? The h divided by square root 12. That's for the rectangle.
Yeah. But where does that 12 come from?
Oh. Well,
I'm sure it would come from somewhere. Oh, so we just square all we add together all the squared gyrations and then divide it by n. And that gives us...
and n represents the number that you have.
Yeah, the total number of different radius of gyrations. But that doesn't give us about the I-axis divided by m, where m is the total mass.
We don't have a mass, do we?
No, but mass is a formula
No, we don't.
of density. I'm not sure how that would come into play. Let's see here. Oh, did you want to derive the identity? Because it's there. But I think, so we'd get a number, and that number would be the magnitude, but we don't have a direction. So that's where the polar moment of inertia, I'm assuming, comes from. Okay. The radius of a gyration about the x is defined as I of x kx squared area. Okay, so ready for this, Jaden? It is going to be the square root of the moment of inertia divided by the area. So it's going to be I
square root
of x square
of the
rated
moment of inertia.
A. And this equals
divided by the area.
RG X. Okay. And that makes sense.
And then same equation for the radius of gyration for the x, right? Or I mean y.
You're right. So you'd have square root of I y divided by A equals
And that's
R.
the area of the whole
That's
shape?
the area of the whole thing. So you'd have to add up all the individual areas to get that.
Okay, we have another comment. I think you can do this problem for something that is 3D, but this problem is only 2D, so instead of mass, you must use area. Okay, so that's what we just figured out.
Yeah. Cool.
Should have read that comment a little earlier. Whoops.
Yeah. Cool. All right. So those are our for that, and then polar coordinates. To change into polar coordinates, Jaden, do we want to go over that really quick?
To change for the polar moment of inertia?
So, because I mean, I'm assuming what that means is we just simply want to switch from, because these equations are going to give us our Cartesian coordinates, right? It's going to give us an x and a y value. And so I'm assuming from there, then we just want to simply switch into polar coordinates with an r.
So I have in my,
or maybe I'm
in my book here, the polar moment of inertia is equal to the moment of inertia on the x-axis plus the moment of inertia in the y-axis.
Oh, never
so
mind.
Once you find your moment of inertia in both x and y, you can just add them together.
Okay, that's a lot easier than what I thought.
Yeah. Okay. Yeah, and I'm thinking it's like there might be an easier way for all this if you just do like a double integral. But I don't know off the top of my head how we would start that, so I'll just try what we have here.
I remember back, I did these integrals a long time ago, but I don't remember how they start out or where we go with them. So we'll just leave it as is for now. Just real quick change here. This is for a rectangle, right? And this is a triangle. But on top of that, this is for I of x. For I of y, the only thing that's going to change is it's going to become base cubed height divided by 12. So just make sure.
So you flip the.
Yeah. So just make sure whatever, this.
Okay.
So this is our x, right? So make sure that this is the number that, let's think here actually. Which one is going to be the one that's cubed? What's our base and what's our height? Let me go back to my.
On the x, it would be.
So the height, so the base is the x in this case. All right, and this is the height.
Yeah.
So this is y. So y equals h, and b equals x. So for this one, this is x, and this one is to y, okay? So you're going to square the x.
Yeah.
You're going to square the x number, or cube the x number when you're solving for y, and you're going to cube the height, or the y number, when you're solving for x. So you kind of switch those, okay? And same thing for the triangle.
Right.
Okay. Well, Jaden, we got that problem done. That was all we had time for tonight. So thank you.
Sorta. Yeah, that was a good question. Made us think, made us relearn some of this stuff. Thank you for your question.
Yeah. Any last minute questions that we can answer for you? Anything that we're missing, or are we good? Anyone got any other questions they want to ask before we stop?
We can wait for a minute because there's probably a little lag, right?
Probably. Hey, Jaden, do we want to... Anyways, Jaden and I are thinking about doing a Christmas special where we calculate how fast Santa would actually have to travel to get to every house in one night. So, if you guys think this is a good idea, let us know, and we will come up with a day to do that. It'll be pretty cool.
Yeah, that would be really cool. We might even throw in some relativity.
Yeah.
Ooh.
Use some Einstein.
Cool. Some time dilation.
We'll get all...
that'd be exciting.
We'll get all... What's that movie called? Interstellar on you. After you learn about Santa Claus, Interstellar will make sense to you.
Yeah.
We could figure out how far, like if Santa Claus was further away from the planet or closer, if he would, Anyways, all sorts of things.
Yeah, be affected differently.
Okay. Well, we're not getting any responses, so I think we are good to go. Thank you guys for watching us tonight.
Yeah, thank you. Remember to like and subscribe if you haven't already.
Yeah.
We'll see you on Thursday.
All right.